In this video, we're going to go through two problems involving gas stoichiometry calculations. In this first problem, we are being told that we have sodium metal reacting with water, producing sodium hydroxide and hydrogen gas, which is collected over water at 25 degrees C. The volume of the gas is measured and its pressure is measured, and we're supposed to calculate the number of grams used in the reaction. So the first thing that I want you to notice when you're looking at a problem like this is that we are given, in this problem, we're given a lot of information about hydrogen gas, and we are being asked to use that information to calculate something about sodium metal. Whenever you're being given information about one molecule and asked to calculate something about a different molecule, that's always your hint that you are doing a stoichiometry problem. And stoichiometry problems always require you to have a balanced chemical equation. So step one is going to be to write a balanced equation. We have sodium, reading the problem, it tells us that we have solid sodium and it is reacting with water. And I'm going to leave some room to add coefficients when I balance this equation. And the products are sodium hydroxide, NaOH, which is aqueous, and H2 gas. And now I'm just going to check and see if it's balanced. One sodium, two hydrogens, 1, 2, 3 hydrogens. So obviously we're going to need some more hydrogens over here. We'll put a 2 right there. 4 hydrogen. Now we have 1, 2, 3 hydrogen. So we'll put a 2 over here. Now we have 1, 2, 3, 4 hydrogen, but that changed the amount of sodium. So we got to put a 2 over here. This one's actually a pretty tricky equation to balance. 2 sodium, 1, 2, 3, 4 hydrogen, 1, 2, 3, 4 hydrogen, 2 oxygen looks good. So let's write the data that we have in this problem just to kind of get rid of the words in this problem. It says the hydrogen gas is collected over water at 25 degrees C. So that means the temperature is 25 degrees Celsius. And let's just go right ahead and convert that into Kelvin because we know we're going to be doing some PV equals nRT type stuff. So Celsius is not going to be an OK unit. The volume of the gas is 246 milliliters, and we'll convert that unit as well into liters, 0.246 liters. And the pressure is 1 atmosphere. And it wants us to calculate the number of grams of sodium. And it says that the pressure of water at 25 degrees C is 0.0313 atmospheres. Okay, so that means that this number right here is actually a P total. The total pressure is 1 atmosphere, and the partial pressure of the water is 0.0313 atmospheres. So we're going to start by using Dalton's law to figure out the pressure of the hydrogen gas. When this reaction is being done, because the hydrogen gas is being collected over water, there's a combination of hydrogen gas and water gas in the space above the water. So we have this total pressure of both of the gases of 1 atmosphere. We know the pressure of water, and so now we're going to use that to calculate the pressure of H2O. The partial pressure of H2O is going to be 1 minus 0.0313. It'll be 0.9687 atmospheres. And again, that's just using Dalton's law. The pressure of the H2 and the pressure of the H2O add up to the total pressure of 1 atmosphere. So again, we're trying to figure out how many grams of sodium we have from all of this information about hydrogen. Whenever we're going from one molecule to another molecule, we do this using a mole-to-mole conversion. That's the point of stoichiometry. So what we want to do here is figure out how many moles of hydrogen gas we have. And we can do that using the ideal gas law, PV equals nRT. But we want to rearrange it so that the number of moles is PV over RT. The pressure we want, we're trying to calculate the moles of hydrogen, so that means we want the pressure of the hydrogen. So I know you got a lot of pressures to choose from here. So the number of moles of hydrogen is going to come from the partial pressure of hydrogen, 0.9 0.247 atmospheres. The volume, 0.246 liters. And then the gas constant, 0.8206 liters, atmospheres, mole, Kelvin, and the temperature, 298. So let me work this math out real quick. 0.9687 times 0.246 divided by 0.08206 and 298. This gives me I'm surprised at how big this number is, 0.974 moles of hydrogen gas. It's such a big number, I just want to double check that I did not do that wrong. It looks like I did do something wrong there. This is a smaller number, this seems better. 0.00974. And I'm nervous because I've gotten two totally different numbers. So I'm actually just doing it a third time. Okay, two times I got this number right here. And so now what I want to do, now that I have units of moles, I can do a mole-to-mole conversion from moles of hydrogen into moles of sodium. And this is using the coefficients from the balanced equation. 1 hydrogen for every 2 moles of sodium. And then we're going to do one last step, converting moles of sodium into grams of sodium, using the atomic mass of sodium, which is 23 grams per mole. Times 2 and times 23 gives us 0.448 grams of sodium for this. Now let's take a look at another problem that's similar. So in this problem, we have some information about the reaction. It says that we have 7.8 liters of hydrogen at 25 degrees C with a pressure of 0.98, and we want to calculate how much zinc is used. So again, we're given information about hydrogen, being asked to use that information to calculate something about zinc. That's how we know that this is a stoichiometry problem, and we'll start with a balanced equation. Solid zinc reacting with aqueous hydrochloric, HCl, to produce aqueous zinc chloride, ZnCl2, and gaseous H2. Balance this, 1 zinc, 1 zinc, 1 hydrogen, 2 hydrogen. We'll put a 2 right here. 2 chlorine, looks good. And let's write down the information from the problem. It's telling us that we have a volume of 7.80 liters of hydrogen gas. We have a temperature of 25 degrees C or 298 Kelvin. We have a total pressure of 0.980 atmospheres. Calculate the amount of zinc that is being used. The vapor pressure of water is 0.0313 atmospheres. So first thing we should do is calculate the partial pressure of the hydrogen gas. The pressure of the water and the hydrogen is equal to 0.98, the total pressure. So we're going to go 0.98 minus 0.0313. And that gives us a partial pressure of hydrogen gas of 0.9487. And now we have enough information to calculate the number of moles of hydrogen gas. That pressure times the volume over R times the temperature. For the hydrogen gas, the pressure is 0.9487 atmospheres. Again, we're just taking the data for the hydrogen gas. The volume is 7.80 liters. The value of R, 8206 liters, atmospheres, moles, Kelvin, and the temperature 298 K. This is going to give us the number of moles of hydrogen gas. 0.9487 times 7.8 divided by 0.08206 times 298. This is 0.3026 moles of hydrogen. And now we're going to do our mole to mole conversion to cancel out moles of hydrogen and convert into moles of zinc. Using the coefficients from the balanced equation, we have 1 hydrogen for every 1 zinc, so that's a 1-to-1 conversion. And then in the last step, we're converting into grams of zinc using the molecular weight, the atomic weight of zinc, which is 65 grams per mole. This is 19.67 grams of zinc.